Hello everyone, I'm Vishesh Vaibhav, and this is a theory class where I'll talk about large language models. So, if you have attended the first theory class where we talked about generative AI, introduction to AI, this would be a good start to talk about large language models. Well, what are large language models? To put it out theoretically, I would say that large language models are those models which are trained on a lot of data, and if a AI system is trained on a lot of data, they know something about the data. So if I am trained on a lot of dogs, I know that okay, this is a dog because I have seen a lot of dogs in my life. I know that if I spot a dog, I'll be knowing that it is a dog. And the same way, I have an example for you. So, for example, in traditional programming, what we used to do was we used to write the code to be able to tell them that okay, this is a cat, is a type of an animal, it has four legs, ears, etc. But when neural networks came, will talk about neural networks further in the slides. But when neural networks came, we could just show them photos and we could tell them this is a cat and this is not a cat, something like this depicted in the picture. And at the same way, when you showed a picture of a cat to them, just like our brain remembers things, the AI system could also remember things. And when it was asked about it, it said yes. Now we have come a long way since then. Like we were talking about NLP and how NLP has transformed the generative AI part. Now we have come to a part that's called generative language models. So Lambda, Palm, GPT-3, they are all language models. We are now at GPT-4, if you which is a paid version for Chat GPT. But yes, we have come so far. So now what happens? How does this work? We say go read this huge pile of books and we train them. So these huge pile of books are actually data, a lot of data. Large here means data. And then we say that okay, you have to read this. Now tell me about among all of this, what have you learned about cats and what are the millions of other concepts? What have you learned? What's a cat? So it will tell you, it will write an essay for you, it will it can tell you different types of cat. Now you just need to feed it data and it will give you a lot of information. Now we need to understand some things about a large some vocabulary to understand what it is. So generative model, Gen AI, generative model is a machine learning model. We talked about that machine learning is a subset of AI. So it is a machine learning model which gives us something, right? We have Leonardo.ai, we have Midjourney, we have DALI. What are they? They give us some image from prompts. They are generative models. We are talking to Bard, we are talking to Chat GPT. What are they? They are text generation models. So it is called a generative model. Large language models are what their main goal is, as we talked about in NLP, is to generate human language and at the same time give us content that feels like okay, this was something that is done by humans. So that is large language models. And as the name suggests, large means size. Like a lot of data is put into the AI systems. They are trained on a lot of data, so they know what we are talking about. So you can ask Chat GPT about anything. It can't access internet yet. Now GPT-4 can access internet, but Chat GPT-3 can't. So how do they know it? Because they have been trained on the data. So if you ask them a question about the present, it says, I'm sorry, I just know about September 2021, because the data set they have been trained on is only valid till September 2021. They would have to be trained on a lot more data from September 2021 to be able to know it. So I hope you understand. So you don't know about a lot of things that will happen in the future because you don't know about it. You have, or if there is a subject you haven't read about, you can't really answer that in an exam. So the same way, they are not able to do that. There is a word called transformer. So we'll talk about neural network in the further slides. But neural networks is actually the like we have brains, the AI systems have neural networks. So what neural network actually tries to do is it tries to replicate the structure of our brain. Like our brain has different veins, our brain has different different architecture which makes us remember things, which makes us think. The same way we have created neural network, which is the basis of the generative models that we have. And this was Transformer was first published by Google in 2017. So generative model, we talked about that. And then comes the neural network. So what is neural network? Neural network is nothing but, as I said, they are inspired by the structure of our brain. So how our brain works, it is what the AI systems are trying to do. The same with data. We see things and understand, and the AI systems understand from data. That's the main difference. Now, what is prompt? So, prompt is nothing but what the text you feel, and the prompt design is how beautifully write the prompt. You would see that right now, if you think that you are talking to a human when you're talking to ChatGPT, so you try to be as casual as you can, but sometimes that results in inaccurate data, because the text that you wrote wasn't able, what the chat gpt wasn't able to understand it fully. That's why the text that you write, the prompt that you write, should be very well descriptive, because the AI knows something, but to take it out from him, to take it out from them, we need to be as precise as we can. Just as our language, if we want the person to understand something we're teaching or something we are talking about, we need to be as descriptive as we can, and the same goes for AI. So here is an example. So zero shot. What is zero shot? For example, say you're talking to ChatGPT and you write a poem about cricket. You have given it nothing. You just say, I want a poem and I want it about cricket. So it will gather all the data it has, and we haven't given it really any information. So it will give us a poem which is something like this. And we really don't know how it got that, because we haven't given it anything to think about. We have just given it, and if it is making something, it is making it up from the data it has. And this is few shot. So what we are talking to the AI model is, we are telling it to convert from English to French. Now what we are doing is, we are giving it a few examples. So we're saying peppermint in French is this, desert cactus is this, and potato is this. Now it knows, okay, that's what I have to do. So it makes the job for the AI easy. At the same time, it makes it faster, because the AI doesn't have to search for a lot of things to understand what our prompt means to say. It can just understand, okay, this person is converting from English to French, and that's what I have to do. So I write the first text in English, and I leave a colon blank, and in the what is bold, what is there in bold, it will give us back, because now it knows that what I have to do. Same way, when we're talking about code generation, how does it know that I'll have to convert from Python to JavaScript? We are again doing the same thing. We are giving it a Python code, and then we're giving it for the same code, we're giving a JavaScript code for that. So it knows, okay, print hello world in Python is console.log hello world in JavaScript. Right. So I then I'll give it a Python code, and I'll ask them what is the JavaScript code, and it'll give me back, because now it knows that, okay, what I am actually talking about. It knows JavaScript. I could just write that, but to make it more accurate, to make it more understandable for the AI model, this is what we do. So this is the instruction, this is the example, this is the input, and we nudge the LLM to output JavaScript. So it does. So this is what it is. Now comes, what is a language model, right? This is the prompt. What we are actually trying to do here. This is a dialogue model. The first one was zero, second was few short, and this is a dialogue model. We are talking to, we are the users, and we are talking to the chatbot. So who are you? It is trying to portray someone. So it would just portray who he is, and it would talk to us like a real human being, because as we talked about, the goal of NLP and the goal of these LLMs are to generate human language, make sure to understand, make sure to depict the humans, that they are really humans and not an AI language talking. So this is what they do. They talk about it like that, and this should be the input. So where do you live? I live in Mumbai, and then I am giving an input, and this should be the answer. So here, what should be the input again? Because as you see, if it asks who are you, it gives you an answer. If I ask where do you live, it gives us an answer. Then it gives us an answer again. But what should be our input? So we must be talked about, what do you do currently? So this is what our main goal here is. We want to customize the chatbot in a way that it gives us an answer where we believe that we are really talking to a human. So that way you do, because this is an example, but in a real world, when you're talking to these Zomato assistants or the Swiggy assistants, they are actually virtual assistants trained on a lot of customer data of what they are actually doing, what they actually talk about when we are conversing with a human, and they are trained on that. So they try to depict themselves as humans, not as an AI chatbot. So this is what this aims to do. And here is something. Prompt design is tricky. So there was this tweet by Andre Karpati. He said that he said that the hottest new programming language is English. Obviously, like, the way you write your prompts is what defines your code. Some people, if you remember, some people were able to take out Windows code from chat GPT, like Windows activation code from chat GPT, if they were able to nudge or provoke the chat GPT model to give us that. And that is how it is. If you are able to make the AI believe that you are really in need of that, and it would give you some examples, or it will give you some prompts or some outputs that it should not be able to, because you are now training the model in the way you want it to behave. This is what we are talking about. The way you are writing your prompt, the prompt design is a science now. You need to be as much as precise as you can to make sure that it really does happen. You are getting the desired output. And this is why now prompt engineers is going to be a big job in the future, because to be a prompt engineer you have to think, and if you think correctly, that's how the AI model is going to behave. Next, there are a few observations that we have to talk about. Hallucinations was one of which we talked about when AUH was talking about generative AI. So LLMs, what they basically do is they should be able to predict the next word. So if they are able to predict the next word in a sequence or the next output, they are not thinking to be truthful by doing that. They don't think that what the statement that I am saying should be true. For example, if you say 2 plus 2 is 5, first it will say that it is wrong. But if you start provoking it, that no, I am right, I know that 2 plus 2 is 5, it will agree with you, because it says it thinks that the human knows better than us, and obviously if the human is telling me that 2 plus 2 is 5, they are right. And you might think that everything that the GPT model or the AI model they generate is true, but sometimes it can be factually incorrect. Sometimes it can be not correct in the making. For example, when Bard came out, it gave us some statements that were true, that really hit their PR low. So something about that. So for example, here is some example about strategy. So if the input is the sky was full of, and the AI model has to suggest the next word in sequence, we have stars, clouds, birds, and dust. In theory, everything can be the next word, but here what we have done is we have given it a few sequences. So which word do we return? Which word should be there? So what we did is we give it a probability. This is probability, and which word has the most probability? This one. This one has the highest probability. So we randomly sample over the distribution. We see, okay, dust, what's the probability? The sky was full of dust. Okay, it can be there, but the probability is very low. So I'll jump to the next, then to the next, then to the one with the highest probability. That is how it selects the word. Now, what is the temperature? This is something that we need to really understand, because we will be using this a lot, and I'll also give you a demo. So temperature is used to tune the degree of randomness. What does this mean? So say the AI model is very random because it has been trained on a lot of data, so it needs to be fed that how much of randomness do you want, do we want in our answers. We want the answers to be very random, or we want it to be a bit of a random. So when the randomness is less, we call it low temperature. When the randomness is high, we call it high temperature. And when the randomness is less, it will be called grid decoding, like we talked about this. less. This is called greedy decoding. The randomness is very less. It is just selecting the word with the highest probability. So that is how that is what lower temperature means. It would generally give us a correct answer because the randomness is low. They don't have to sample over a lot of distributions like we did here. We just select the one with the highest probability, and that's why it is a lower temperature. Whereas higher temperature is when we want it to sample over a lot of distributions and then give us a creative response. Sky is full of dust. We don't really hear that, right? But it is factually true. So it is getting a bit more creative in selecting that. So we are increasing the temperature, resulting in a lot of creative responses from the AI model. So that is there, and this is what it is. It is a number that is used to tune the degree of randomness. This is what we discussed. And top k and top p. So top k is actually the number of samples we want. So this you can see is something that you will be using when you are using the cloud console. It is the temperature. We talked about that. Token limit is the number of samples. Token limit is how many samples do we want, and then top k is number of samples we want it to skim through, and top p is the probability. Like this is the probability we talked about in that. This is the probability. So top k is the number of samples. So from token we want k equal to 2. So it'll take 2 and then add the probability of the samples. It'll add the probability of the samples and then it will give us the top p. So you'll understand it better when we are doing it in the practical part. So as we talked about, what are LLMs? LLMs are nothing but they are algorithms, ML algorithms that can recognize, predict and generate human languages. They are pre-trained on a lot of data, and this is how they do what they do. So we talked about this, and research, conversation, content generation, LLMs are able to do all of that. I'll be sharing the PPT with you as well. And this is how LLMs are applied in the industry. We all know this is happening, right? Customer support, it is there. Technology, it is there. Financial services, it is there. Everything, everywhere AI is taking over. And sometimes it's good, sometimes it's bad. But that's the truth. And in traditional machine learning development, we needed thousands of training samples to get started, obviously, and we needed machine learning expertise, because if you don't know what to feed, you couldn't actually train it. But now what has happened, that we need zero training examples and we need zero ML expertise. Like obviously to be an expert we need to know something of this sort, but to get started we need nothing of this sort. And we don't need to train a model, because it has already been trained on a model, a lot of models, and machine learning learns from the models that we are training it on. So we need to train it on a lot of examples, and large language models have already been trained on them. For example, ChatGPT, we don't need to train it again and again in order to get an answer from ChatGPT. That's what it is. And things about prompt design. And what does Google offer? So Google has, for consumers, it has Bard plus Maker Suite, and for enterprises we have Vertex AI and Duet AI. We'll be working on Vertex AI as well, and this is what Google is doing for the family of models. For consumer, they have Enterprise, AI Builder Enterprises, models for AI builders, and this is what it is. The Palm 2, Code, Imagine. We'll talk about everything when we are doing the practicals. So I hope you're excited for that. So this is the Cloud AI portfolio. For AI practitioners, these are the things what we are using. For developers, these are the things, and for business users, these are the things. And a lot of that we'll be using. So for text, we have Palm, Palm for chat, Imagine for text to image, and to be very, to make you excited for that, we'll be using all of this in that Google Cloud Console. And this is a generative AI studio which we will also be working on, so please be excited for that. And the next thing that I'm going to do is give you a bit of a demo of the generative AI studio. You know that what I'm talking about. So you will be building a ChatGPT kind of thing on your own, and you'll be actually using it. So isn't that pretty interesting? Let's do that. Let's jump onto that. Now this is where your magic happens. So I have opened a Google Cloud Console. You don't need to do this as of now, because when we will be starting with your the labs that we'll be completing. I'll tell you how to do it, but here's a quick overview, and here's, you don't have to follow this. Follow what we do in the labs and when I'll be sending the videos, and if you're completing it by yourself, then well and good. So this is the basic UI of your lab. This is how your Google Cloud Console should look like. And then say what we are right now we're gonna do is we enable the API. So you know what is this, IAM and roles are assigned here. You don't need to really get into this, but what we are really concerned about is making our own chat GPT kind of thing, which you will be doing in the labs, but I'm just giving an overview for the sake of this video. So what we'll do is we'll write Vertex AI. I'm doing this, you don't need to do this. And after getting on the Vertex AI, I'll be enabling all recommended APIs because we want to do something, right? And then I'm enabling it has been enabled. Now what I'll do is I'll go to language, because that's what I'm trying to do right now. I'm trying to make a chat GPT of my own, right? So after I'm here, I'll go with the text prompt, right? Now, what is free from, what is structured? This is a bit of a theory also, so I need you to understand. So I am here on the language part, and I am designing my own prompts. Here I can have a conversation, and here I can tune a model. So you can always go here and take a tutorial on how all of this is done, but I'm giving you a insight on how this should be done ideally. So I'm going on the text prompt and say I'm talking to a chat GPT of my own. So this is the UI you saw in the slide, right? So right, what do I need to do then? Well, for example, I'll give you an example, okay, where okay, where is New York, right? It should be coming to us. You must be thinking this can come through us through a normal Google search, right? All right, what I'll do is I'll do nothing. I'll just adjust the temperature as we talked about. This is the level of randomness. I'll show you after decreasing and increasing that. So after I click submit, it should give me something like this. Is a state in the northeastern United States. What if I increase the temperature? So you remember, higher temperature means high level of randomness. So this is what it gave me. It is gave me a shorter answer. Okay, cool. Now this is what we talked about. But remember, when we were talking about introduction to AI, we talked something about sentiment. It can sense a sentiment of what we are talking about. So here is what we will do. What else in your name? Alright, so I'm here in Gurugram. It's giving me these locations. Alright, let's go with somewhat this. Okay, and let me just copy say I'll go to reviews, and then alright, so what I'll do is I'll just copy, let's just get a 3-star review. It'll help us a lot. Okay, let me just get something for you that would help us a lot. Alright, so I've copied this one, and now what I need to do is let's just paste this and see what it gives us. Alright, the level of randomness, let's give it a 0.5 and just paste this. Let's see what it gives us. So it's giving us a sentiment analysis, because see what the prompt says. Below average place to stay, service is poor, staff is not active. Okay, it sounds like you had a very disappointing experience, service was poor, this. Okay, now what I want to do is this review positive or negative. Let's see what it gives us. The review is negative. All right. And if is this give it give me a list of negative points from this review and give it uh, give it a all right give me a list of negative points from this review and give it a percentage. So I'm trying to make it a bit more, and top P and top K can be adjusted if you want, but they're not really helping us do something. All right. So the review is negative, and these were the negative points, and the percentages gave is 66.67%. All right. How did the percentage came up? Well, if the and this is that negative review of 66.67%. So if anything he liked must be in the remaining 33 point something. So this is what it does. When we gave this AI model only this example of the review, it gave us that okay, this is a negative review. It understood that it had a this is what we call the sentiment analysis. It understood okay, this is what the person is talking about, and this is what it is. It gives us the AI model is giving us a sentiment analysis, and this is what this does. We asked it if it's a positive or negative review. We wanted a negative points from them. It gave us that, and it also gave us a percentage of the negative points in this. So how negative was it? It was 66.67% negative. So this is what it is. But what about structured? What is this? So structured is what we talked about. Say, if we write India, Mumbai, example output. Okay, if I write Washington, now let me just write Delhi here. Delhi, Washington DC, and then I'll write USA. Then let me just write any more. Okay, Beijing and China. So what will happen here? If I were to actually write a test input, for example, anyone, so for example, Caro, right? Let's see what it gives us. Egypt. So it knows what I'm talking about. I am talking about the capital of the countries, and it just searches its database. Okay, what is Delhi to India? What is DC to USA? What is Beijing to China? Okay, they are capitals. So that is what Cairo is to Egypt. It is a capital, right? This is what we're talking about. So this was a bit of a example of what you can do with it, and obviously you can save this, and you can say capital, and I can save this, and I can always access this from here. So if I need to access this, I can go to it's loading, and then if I need to just access it, I can load it from the save button which is there. So I don't know, it's taking some time to load, maybe there's some issue, but yeah, this is what it does. So if anytime you want to talk about how ChatGPT was made, this is what we are talking about. We adjust the top K, the top P to get varied answers, and this is what it held. This is what it does. So I hope you understood something about that. And right now we'll so yeah, it is saved in my prompt, so you can access that. So this was that, and now we'll talk about we'll complete the first lab with you. So you can do the same with vision, like we did with text, and here is the one with the code prompt. This was the text prompt, this was a code prompt. So you can do the same thing. You can experiment when you're doing the generative AI. You almost have a lot of like 1 hour to complete it. So you can try, and you can do what you want to do. You can also do a speech one to get a visual description. I don't have an image, but when you will be doing it, you would understand what I'm talking about, and you can do the same with speech. So it is a very, very amazing studio, generative AI studio. It does a lot of things, and it's very interesting, and I invite you to explore this. So when you will do it, we will be doing the generative AI studio, or if you are doing it by yourself, be sure to explore the Google Cloud Console to its fullest, because it's full of things that you would want to explore, and it's a lot more enjoyable. Thank you so much for this, and I hope I'll see you again in the next video. Thank you.